We've created this program to help you better serve your customers with gasoline direct injection engines. GDI engines have a problem that can seriously hurt your customers' vehicle performance and fuel economy. But the solution is fast and easy for you, and it's affordable for them. To go through the program, use the navigation buttons at the bottom right and watch for a couple of quick quizzes along the way. Let's get started. In the past decade, gasoline direct injection engines have become extremely popular with both domestic and import auto manufacturers. Compared to conventional fuel injection, GDI can deliver improved fuel efficiency, more power from smaller engines, and reduced emissions at low load. That's great. But the popularity of GDI engines has brought back an old service issue: carbon deposits that can rob drivers of horsepower, gas mileage, and smooth operation. So why do carbon deposits happen in GDI engines, and how can you help your customers? Let's have a look. Conventional multi-point fuel injection injects fuel into the intake tract or cylinder port at low pressure. With gasoline direct injection, or GDI, a common rail fuel line injects highly pressurized gas directly into the combustion chamber of each cylinder. The improvements in power and fuel economy come from the extremely precise control that GDI engines have over the amount of fuel delivered and injection timing. Fuel and timing are adjusted multiple times per second according to engine load. Plus, some GDI engines operate on full air intake with no air throttle plate, which further improves efficiency and reduces piston pumping losses. Instead of having a throttle plate that restricts the incoming air supply, the engine speed is controlled by the ECU and the EMS, which regulate fuel injection function and ignition timing. But as with many technology advancements, there's also a downside. When conventional multi-point fuel injection injects fuel into the intake tract or cylinder port, gasoline washes over the backsides of the valves. Modern gasoline, with its package of detergents, is an excellent cleaner. So, in conventional engines, gasoline keeps the backsides of the valves clean and free from deposits. But since GDI engines inject gas directly into the cylinder, gas never reaches the back of the valves. When fuel is no longer washing the intake valves on the way to the cylinder, small amounts of dirt from intake air and blowback carbon from the crankcase ventilation system build up and burn onto the intake walls. The result is carbon deposits forming on the valves, cylinder heads, and injectors, and that's where the trouble begins. Over time, the carbon buildup on the intake valves reduces the airflow to the cylinders, and that reduces torque and horsepower and hurts fuel economy. The carbon deposits on the cylinder and cylinder head can cause pre-ignition, rough starting, and rough idling, as well as foul spark plugs and misfire codes. The buildup can become so severe that pieces of carbon can actually break off and burn a hole in the catalytic converter. Many modern GDI engines face a double challenge because their variable valve timing keeps the valves open longer to maximize the scavenging effect and minimize emissions. That leaves the valves exposed to carbon particles in the cylinder longer, and that means more carbon buildup. How big of a deal is the GDI carbon deposit problem? It's big, and it's becoming huge. Gasoline direct injection was actually first invented in 1902 by the French inventor Léon Levavasseur, who also produced the world's first V8 engine. But as of 2008, only 2.3% of passenger vehicles used GDI engines. By 2015, the number was up to 45%. By 2021, roughly 80 million vehicles in the U.S. will have GDI engines. And more cars with GDI engines means more service issues related to carbon deposits. And that means more customers who need a solution. Until recently, removing carbon buildup on GDI intake valves had been difficult and costly. Labor-intensive processes such as walnut shell blasting and manual valve cleaning required an engine teardown to access the valves. It was hard work and a very hard sell to many drivers. Before GDI engines became popular, fuel additives were used to treat carbon buildup. But with GDI, neither the additives nor the fuel would reach the back of the valves. But CRC has an affordable solution that your customers can easily get on board with. Scientists have found that the chemical polyetheramine, or PEA, when applied in strong concentration and under the right conditions, can effectively clean hardened carbon deposits from GDI valves and other engine surfaces without blasting, brushing, or any teardown required. CRC has used this discovery to create a GDI carbon deposit solution that allows you to tackle the problem quickly, easily, and at a very reasonable cost. CRC GDI IVD intake valve and turbo cleaner is an aerosol spray that's applied through the engine's air intake or throttle body and delivered directly to the backs of the GDI intake valves. CRC GDI valve and turbo cleaner contains the highest concentration of PEA available on the market to provide the fastest, most thorough chemical cleaning available. A single application removes up to 46% of carbon deposits in the first 60 minutes. With the ability to clean heavily baked on carbon deposits the way it does, you might ask, is it safe? Yes, CRC GDI valve and turbo cleaner is safe and effective for all gas-powered engines, including turbocharged and supercharged engines. It's safe to use every 10,000 miles or at every oil change, and it's safe to use for O2 sensors and catalytic converters. But it should not be sprayed directly on a mass airflow sensor and should not be used in diesel engines. High temperatures can cause carbon to stick to turbocharger turbines, housings, and wastegates. The turbine blades and oil seals are fragile, and carbon buildup can eventually cause significant damage. But the same cleaning action that removes carbon deposits from valves and pistons cleans turbo impellers as well. On turbo engines, CRC GDI valve and turbo cleaner can be sprayed directly through the throttle body or through the air intake, but again, never directly on a mass airflow sensor. Okay, here are some real-world independent lab results that prove the effective cleaning power of CRC GDI valve and turbo cleaner. Here's a 2011 Hyundai Sonata cylinder head before treatment. Before treatment, the carbon deposits averaged 9.89 mils in thickness. You know that's going to contribute to a tendency for pre-ignition. Now here's that same cylinder head after an hour of treatment with CRC GDI valve and turbo cleaner. The carbon deposits are nearly gone. The average thickness is down to 1.5 mils. The deposits were reduced by 85% after the first hour. Now have a look at the intake valve from the same Sonata. After the first hour of treatment, the deposits are reduced by 24%. Take a look at these fuel injectors. Also from a 2011 Sonata, before treatment, they're heavily caked with carbon, and the flow is being impeded around the injector orifice. After the treatment, the valves look almost new. 100% of flow has been restored, and the spray pattern and fuel droplet size are once again optimized for increased fuel economy. Here's a cylinder top from a 2009 Cadillac CTS. Carbon deposits average 8.59 mils in thickness. After the first hour of treatment, the deposits measured 2.77 mils, a 68% reduction in deposit thickness. You might wonder why these test results say after the first hour. That's because the carbon cleaning action will continue for several days after the treatment. As the car is driven, additional carbon that's been loosened by CRC GDI valve and turbo cleaner is safely removed by the heat and pressure of engine operation. Take a look at these dynamometer results for a 2015 VW Passat 1.8 i4 Turbo. The vehicle measured an impressive 5.6 peak wheel horsepower gain 2 days after treatment. but it picked up an additional 6.9 peak wheel horsepower gain when measured 8 days after treatment. Here's another bonus. CRC, GDI, valve, and turbo cleaner will also work to clean carbon deposits off spark plugs without the need to remove them from the engine. And finally, here's proof that CRC, GDI, valve, and turbo cleaner does really work for turbos. Here's a 2013 Mini Cooper Countryman turbo impeller before treatment, and here it is after treatment. The results are dramatic. You can see all our test results at crcforshops.com. The tests are real and so are the results. CRC GDI IVD intake valve and turbo cleaner really does remove tough carbon deposits from valves, piston heads, fuel injectors, and intake manifolds quickly, safely, and without an engine teardown. First, just as you would with any product, read the entire product label before using so you can understand the instructions and the safety guidelines. Next, warm up the engine. CRC GDI valve and turbo cleaner requires a period of heat soak to work, so you want to start with an engine that's fully warmed up. Locate the throttle body or air intake and spray the product directly through the throttle body. If the throttle body is not easily accessible, spray past the mass airflow sensor, but do not spray into the mass airflow sensor assembly. You can also remove the mass airflow sensor assembly and spray where the sensor is mounted. If the vehicle is turbocharged, you can remove the boost sensor and the charge pipe and spray into the pipe. If it's easier, you can also spray into the vacuum port. Lift the PermaStraw dual action spray system and lock it into place. With the engine running at 2,000 RPM, spray in short bursts until the can is empty. Once the can is empty, rev the engine 2 to 3 times but don't exceed 3,500 RPM. Run it idle for 1 minute, then turn the engine off. Reassemble the air intake system and let the engine heat soak for a full hour. The heat soak is critical, so be patient and let the CRC, GDI, valve, and turbo cleaner do its work. After the hour is up, restart the engine and drive at highway speeds for at least 10 minutes. And remember, as our test showed, the maximum benefit is achieved when the vehicle is driven regularly over the next several days. So let your customer know they should drive the car regularly over the next week or so. If you have a vehicle with severe carbon buildup, CRC, GDI valve, and turbo cleaner can even be used in successive treatments. Just have your customer drive about 1,000 miles before a second treatment in order to get the full benefit of the first treatment. GDI engines are not the only engines that get carbon deposits. Conventional fuel-injected and carbureted engines can suffer from carbon buildup too. CRC, GDI, valve, and turbo cleaner is safe for use in engines with port fuel injection or carburetors. You can apply the product in the same way as you would on a GDI engine, right through the air intake. For automotive service providers, the GDI carbon deposit issue means an expanding service opportunity. Anytime a customer comes in for an oil change or regularly scheduled service, suggest treatment with CRC, GDI, IVD intake valve, and turbo cleaner. It's fast, affordable, and has real benefits for your customers. You'll be helping to preserve their gas mileage, horsepower, and vehicle life while adding a nice boost to your sales as well. Well, that's it. Thanks for taking the time to learn about CRC, GDI, IVD intake valve, and turbo cleaner. We hope you'll make it a part of your regular service for your customers with GDI vehicles. We believe they'll appreciate that you've given them an affordable way to preserve their vehicle's performance and protect their investment.